Today's lesson is on horizontal and vertical distances, and it will cover pages 152 and 153. We'll start by looking at questions 1, 2, and 3 because they're all quite similar and also a little bit related, and they reference each other. So question 1 asks you to use figure 1, which is here, to find the horizontal distance between points. So remember, horizontal is side to side, which is why we have these horizontal lines here. So the horizontal distance between 2 and 0, so if we look here, there's 2 and 0, and 7 and 0 is, so count how many units? 1, 2, 3, 4, 5 units. Then we have two new points. So the horizontal distance between 2 and 1 and 7 and 1 is, so count how many units that is. 2 and 3, 7 and 3, count how many units. So when they say 2 and y and 7 and y, it means 2 and any y value and 7 and any y value. So it doesn't matter whether your first number is here or here or here, right? As long as it makes a line, how far apart is it? Question 2 asks you to do something quite similar with figure 2. So the horizontal distance between -5 and 0 and 2 and 0 is, so count how many units across this is. Make sure when you're counting, you wouldn't go 1, 2, 3, 4, 5, 6, 7, 8. You would actually go to the boxes that are in there. 1, 2, 3, 4, 5, 6, 7. So that would be 7 and not 8. Just something to be careful of. So find each of the points and say how many units it is. Question 3 asks you to look at your answers to questions 1 and 2. Does the horizontal distance between 2 points on the same horizontal line, so the same horizontal line, depend on the x-coordinate or the y-coordinate? So is it the x value that determines the distance, or is it the y value that determines the horizontal distance? Before we start question 4, they'll give you a little reminder in your book that the distance between -2 and +3 is the same thing. We can write this as like a subtraction question to get the distance between these two numbers. So you could say 3 minus -2 is the same thing as 3. Remember, when we subtract a negative, it's the same thing as adding a positive. It's the same thing as 3 plus 2, which is also just kind of the two gaps. 3 plus 2, so the distance is 5. So they're asking you to subtract the x-coordinates to find the horizontal distance. So your x-coordinates would be, here we've got -3 minus 1, right? These are our two x-coordinates. So that would equal -4. Now this is the only case, because we're doing distance, you can ignore the negative sign, and our distance is just 4 units, okay? So you're subtracting the x values, but you can ignore the negative if you need to. Or you could just start with the number that's on the farther right. For question 5, they ask you to use figure 3, which is over here, to find the vertical distance. So vertical distance will be up and down. So 0 and -2 and 0 and 5. So here's 0 and -2, 0 and 5. How many units? So remember, you're counting how many kind of side lengths of these squares are there in between. So you'll do that for each of these. X minus 2 and x5 are basically just asking, our x value is changing each time, but if it didn't, right, how many units would it be? What is it for all of them? And then question 6 asks you to subtract the y-coordinates to find the vertical distance. So we're kind of doing the same as question 4 here, but this time we're subtracting our y's. So we've got -3 and 2. So -3 minus 2 is -5, but I don't need to worry about the negative sign because it's still 5 units. It doesn't matter which direction it goes. After question 6, you will then have a rather large investigation section before you have your final question, question 7. So what we're trying to discover in this investigation is how do coordinates change under translation. So if you remember, we have a few different types of transformations. A translation is what in younger years you would have referred to as a slide. So it's when you just shift to the side or shift up and down. So a point is moved 4 units right. Find the new coordinates. So we started at 1 and -2. So here's x1, y -2. It goes 4 units to the right. 1, 2, 3, 4. This is where a dot ends up. So you need to write in the x and the y value. So the x value becomes 5 and the y value stays -2. You will do the same thing for each of the following questions. This one I know it's kind of tricky to see, but it's just on the axis right there. Which coordinate changed during the translation? The x coordinate or the y coordinate? So you're looking, was it the x coordinate that changed or was it the y coordinate? Look for the pattern. So either x or y coordinate increased by how many? Write an algebraic expression describing the change in the x coordinate. Use x as a variable. So x becomes, could be like x plus something. Use your formula in part C to predict the coordinates of these points after a slide 4 units right. So if E is here, which value changes and by how much? What do we add? So you'll do that for each of these. Then you'll plot points E, F, E apostrophe and F apostrophe. So what you might notice, and I might actually zoom in here a little bit, is when we are writing here, we have E and we have E translated. So this little apostrophe means it is the transformation of this original. Okay, so this is almost the copy of it. So you need to label both the original and the new one, but you need to make sure that you have the apostrophes for the translated or the transformed shapes. Okay, and you will be plotting these points on this grid right here. Okay, so you're doing all 4, E, F, E translated and F translated. Then you're going to write an algebraic expression for the x coordinates. So point xy slides 3 units right to point. So what will happen to x? It'll be x and then plus or minus something. So if it's going to the right, it's probably going to increase. So it'll be like a plus, and then how much do you add to it? Plot 3 more points and their images after translation to check your expression. So you could find 3 more points and see, does it make sense? For part G, you're going to slide or translate the point P as directed and write the coordinates of the new point. So 2 units up. Here is P, okay? And then this is P translated. They asked you to bring it up 2 units. So that's why it's here. And then they put the new coordinates. Your original one was 3, 2. Your new one is 3, 4. Here's P. It asks you to move it 2 units down. So you have to go there and then find what's the x coordinate, what's the y coordinate. 2 units to the left. And then write the names of the coordinates. So at the bottom, you'll say what increased. So here, the x coordinate stayed the same, but the y coordinate changed. The y coordinate increased by 2. Okay? So here you'll have to see which one changed, the x or the y. And so if it's the x that changed, then it's the x coordinate that will have an effect, or the y coordinate. And then does it increase or does it decrease, right? 2, an increase of 2 gets you 4. So 2, what happens? The final question is question 7. So point Q is x and y slid to point Q translated. So we're matching the coordinates of Q translated to the description. So we have blanks and then we have 4 descriptions. So we have to figure out which one matches. So if x plus 4, so if your x value increased by 4, that's the same thing as moving 4 units to the right. So that is why they wrote D here. So if your y decreases by 4, is that moving up, down, left, or right? If your y increases by 4, is that moving up, down, left, or right? And if your x decreases by 4, is that moving up, down, left, or right? Okay. This will probably be the question that I use for your Google form to help see if you're able to understand a little bit of this lesson. If you need any help, please do not hesitate to send me a comment, ask for a Zoom meeting, and we will help this make a little more sense.